All right. Well, hello, everybody, and welcome to another episode of React Wednesdays. We got a super fun show here today. My name is TJ Van Tol. I work as a developer advocate at Progress on the Kendo React team. And with me today, as always, is Dan Wilson.
Hey, I'm Dan Wilson. I work at Digital Primates. We do enterprise React consulting. We also curate the enterprise React newsletter. So if that's your cup of tea, Google it, subscribe. We won't spam or sell your information.
Awesome. And our guest today is, and hopefully I get this right, Matan Borenkraout?
Yeah, great.
I got that. Matan, you want to introduce yourself?
Yeah, sure. So, hey, everybody. My name is Matan Borenkraout. I'm from Tel Aviv, Israel. I work at Nielsen Marketing Cloud as a front-end engineer. I work with React since 2016. That's it.
Shalom, Matan.
Hi.
So today's topic is pretty interesting to me because we're going to talk about a little bit of everything around sort of concurrency, scheduling, threading, which is a very interesting and also potentially very confusing, I guess, topic. And I think especially in the React space, because there's lots of different moving pieces and APIs and such. So Matan, do you want to set the stage for us about what is the current state of concurrency? And I guess what sort of problem are we trying to solve or talk about?
Yeah, sure. So maybe we'll start with the demo and then we'll see the problem, and then let's talk about how can we solve it and what React are doing. So
yeah, I can switch to show your screen here if you're ready.
Cool. Yeah. So we can start. Just a quick disclaimer. This demo is based on a demo that Philip Spice, I think, made. I'm not sure I pronounced it good, so I'm sorry if I didn't. So what we can see here is an app. It shows Pokemons. You can see in the header that I'm using request animation frame in order to change the colors in each frame that I'm showing. And we have something like 200 Pokemons here. We also have frames per second. I'm showing at the bottom, so we can be able to see how many frames we're actually rendering to the page at each second. So what I'm trying to show here is actually the problem. So what happens now is that I wrote Bulbasaur, and you can see that the whole screen actually froze. So let's see it again. You can see that the animation frame, the animations froze, and the frames per second dropped to five frames per second. And that's really low. That's not the user experience we want to supply to our users. We can see here that the minimum we got was 2.5 frames per second. And that's it means that the screen was stuck for a very long time. So that's the problem we want to solve here today and we want to talk about.
Yeah, and I guess, so why is it slowing down? I guess, is it because it's rendering because it's doing some rendering job and that's potentially expensive, that it's actually blocking the user typing in this case?
Yeah, that's it. That's a very good question, and that's exactly the point. So I'll show the code, and what I actually did was I wanted to create the slow rendering time. So what I did was I created a Pokemon's list component. We can see here that we have Pokemons, and in every Pokemon that I render, remember I have 200, I actually simulated a sleep. That's a sync sleep. It means that I'm running with a while loop, and I want to check if the time is actually past the time that I wanted. And you can see that I'm sending 2 milliseconds. It means that I'll actually go on a while loop and wait for 2 milliseconds, and then the whole render happens to be very, very slow. Okay.
Yep.
So this is a sleep thread or a sleep bit of work, and some people watching might go, "Well, I don't add sleeps into my code," but perhaps we can explain this as some kind of analog for work that's being done on a calculation or fetching or something. Can you kind of walk a little bit into what a real world issue might be?
Yeah, so exactly. The stuff you pointed out are exactly the use cases. So if you have some heavy computation that you do on the main thread as a result of user typing, so maybe a search as you type and you have an autocomplete, and you do some heavy computation to gather the list of the autocomplete options, So that's exactly the point. I mean, every one of us went to a site and started typing in an input, and it happened, and the site slowed down immediately, and we didn't know what happened. Is the site even responding? What am I doing here?
Yeah, and it's quite common for people. And we get Jay Noel says, "Figure yourself like you, it sleeps to my code." We're just behind the times. You know, I've totally ran into this situation before where like sometimes these filtering lists, what they're actually rendering are crazy complex, right? Like, so I work on Kendo React, and we make a lot of components that are like, you know, enterprise level. Like there's a lot of things moving around, and lots of times people will render these things in lists, right? So you search for something, and like there's little charts and graphs in each individual item being rendered. And it doesn't take many of these, and it's not like a symptom of like the component. It's just a thing. There's just a lot to render, a lot of work for the browser to do. And you're expecting the browser to get all of that done before the user moves from like typing B to typing U, right? Like that, like, I don't know how many milliseconds, but not many, right? For the browser to do all of that work. So I kind of like this. That's a handy little trick. The while loop thing to actually sort of simulate more complexity that you get in a sort of reality.
Yeah, the way I kind of think about this, and sometimes computers can be mysterious, but we've all sort of drawn in animations on a flip book and then flipped the page to watch the animation happen. In fact, I regaled my 7-year-old with how to make cartoons recently using this trick. And so if you imagine the page is flipping 60 times per second, that's sort of the ideal frame rate for smooth animations. And if you start dropping frames because of work, each frame basically breaks down to about 16 and a half milliseconds, if my math is right. And so if you do work for a little over 16 milliseconds, you drop a frame. I don't know how noticeable dropping a frame is, but I mean, obviously you've put a case in here that, is it dropping 400 milliseconds worth of work?
Yeah, so exactly, the magic number is around 16.3, I think, milliseconds for a frame. But for as far as I read in researchers, probably if you won't step over 100 milliseconds, the user won't probably notice it. So if you're very good at noticing stuff, then you probably notice 50 milliseconds drop. But 100 milliseconds and above, everyone will notice it. And what I'm creating here is exactly the point. So I'll just run a profiler for a second, so we'll see the specific amount of time that it takes to render the stuff I'm doing. So I'll record it, and then I'll write Balbazzar. Let's wait for it to stop freezing, and now we can see it here. Yeah, just a second, sorry.
Such pretty colors. And by the way, because your example has Pokemons, you've made TJ's day. Like, he literally is probably throwing confetti in his office just to be able to talk about Pokemon.
I always appreciate a good Pokemon demo. Hey,
Cool.
In my defense, so background here, Dan used to yell at me for making Pokemon demos because he would say they're not real world, right? People aren't actually building Pokemon apps. But the thing is, like, if you need an app with a large data set, like there's so much data in the Pokemon world that it like lends itself to these sorts of demos so nicely. It's just hard to not write a Pokemon demo, quite frankly.
Well, yeah.
Plus, it turns out people are writing Pokemon apps because we're looking at one right now. I stand
Yeah.
Yeah. So basically, what we can see here is I'm using the profiler tool in the Chrome DevTools, and what we can see here is that actually we have all the frames here, and we can see that it's stuck around here, and it kind of loses around here after all the event handlers finished. So we can see here that's a key press that I did. You can see that it took 429 milliseconds. So it means that basically the browser didn't have time to go ahead and paint the changes that he had, because I wrote pretty fast. I'm writing fast. So it didn't have the time to do that. So in 429 milliseconds, the screen was frozen. And then we have another one and another one going on until I stopped writing, and he stopped actually working on the changes. And then we can see here all of the other stuff that the browser actually saved because it didn't have time. So maybe we can see here the paint here is something the browser needs to do in order to update the UI. And we have also animation frame fired. I think we'll probably find here like a garbage collection or stuff like that that we actually stop the browser from doing because we block the main thread for, I don't know, 4 seconds, something
There's
like
a
that.
lot in this profiler. This is probably takes a minute to learn how to interpret it correctly, but I can see everything's right here if you know how to read it.
Yeah, basically the triangle, the red triangle here, it's the one that's telling you, wait, you had something wrong here. Something took way over what it was supposed to take. So that way we can understand what happens.
So I think the logical follow-up question here is then, so how do we address this, right? Like what options do we have available to actually fix this, or like offload the rendering, or what do we do about this?
Yeah, so basically there's another small thing I didn't say, and it's important to notice. Besides of the slow render time, I also had a little something at the side. It's called send analytics ping. Actually, what I'm doing here is some sort of computation that isn't related to the render phase exactly, but it's something that shouldn't block the main thread. I mean, we can send analytics whenever we want. We can send a message to the server saying the user did this and that, and even if it needs some heavy computation, we can do that last. We can do it whenever the browser has time to do it. We don't need to do it immediately when the event handler was triggered. So what I did here is actually the performance mark is for my performance, the profiler, and I also used the simulate sleep. It just took me some more time. I just sent 25 milliseconds because I wanted it to be slower. And I just wanted to emphasize this one because I see a lot of times some stuff that people do that don't actually have to happen this moment. It can be postponed later because the user doesn't really notice it. And what we want to do is we want to save the render time or the CPU time for stuff that the user actually sees and actually can interact with. So stuff like that, like heavy computation that can be done later, it's better to send it to the time where the browser has time to do it.
Can you hover over that send analytics ping thing again, the way you were showing it?
This one?
So it looks like what you're doing here is making a closure with the timestamps in the closure and then handling that closure later. So the timestamps are recorded in the context. You don't have to process that yet because you have the data that you need. Is that the general idea?
I'm not sure I got the point. Can you say that again? It looks
like you're taking a snapshot here with this piece of code and then later processing it when it's convenient for the browser to process it. So you're not losing any data, you're just deferring the processing of it.
Yeah, so at the moment, the only thing I'm doing is for the code that I'm showing now, it actually does stop the browser. It actually simulates a sleep for 25 milliseconds. What I did here in the performance mark, the analytics start and the analytics end, is the stuff that I wanted to show is that it happens actually as a part of my render. So you can see it here. This is the performance mark are actually for the developer tool. So I'll be able to see when that function was called. So you can see it here that it is marked here. And we can see that it actually happens after every time we have a slow render, after every key press. What I did was I sent the analytics ping, and the performance mark is just so I'll be able to see it here, and it doesn't have any implications on the user or the code. Okay.
Yeah, I think where some developers get into trouble is they're coming from maybe a model where you sort of do everything, in a procedural fashion, and they're not used to the idea that you can defer work or even at a level of understanding where they know what work is deferrable.
Yeah, I mean, I've wrote JavaScript code for 13, 14 years at this point. I don't think I've ever in a production app like offloaded processing, right? Like even in cases where now looking back, I probably should have, it's just not the mindset you approach things with. You just think like, yeah, whatever. Like I'm going to throw up a loading screen, right? Like, so that'll be fine. It'll just put
That's
a,
right.
it'll
I
just
remember
show a
those.
spinner while it's processing, but I show a spinner, so it's okay.
And I think it's also fair to point out that 13 years ago, the whole app wasn't running in one single context. So, you might have, say, in a jQuery app, some enhanced functionality, and it's basically a post response page where the page and UI is rendered, but then you're decorating that UI with some extras. And now the model is totally different, where the entire app is meant to run in one context, and you have to be responsible with the UI thread. Otherwise, you kind of run into the problem we're here to discuss, is drop frames, janky applications. And sometimes the worst part about these types of things is you get the works on my machine model, because if I'm testing locally and I'm using a local server with no data in it, it's perfectly fast. And then once you get outside that into the real world, bad things happen.
Yeah, that happens to all of us. So yeah, basically, if we want to talk about the solutions, so I think that every JavaScript developer and TJ, to come back to the example you said before about rendering stuff inside a list and very heavy rendering, or even a lot of lists with some render inside it, people will probably say, yeah, you can debounce it or throttle it or whatever. So that's probably the first solution that comes in hand, right?
Yeah, and debounce basically means, if I'm remembering it's basically says, okay, the user types an A, but let's give them a bit of time. Let's don't immediately like render with the A filter. Instead, let's wait like another 100 milliseconds to see if they type another character first, so that like if you get a user that types Bulbasaur really fast, you're only going to render when they get to the end of it, right?
Yeah, exactly. So that's our solution for everything. I think that if there's an autocomplete, you can just debounce it, and then what actually happens is that you give the user a weird experience. He starts typing, and if you debounce for 200 milliseconds, then he doesn't see what he's writing for 200 milliseconds, and that's pretty weird. We don't want to give that sort of experience. And then you have some other solutions, and these don't really work the way a proper user experience would behave.
So what do you recommend, and what are you going to use here?
Yeah, so basically what we're talking about is the async solution, Concurrent React, if you want to say. Concurrent React is still experimental. What I'm showing here might change. It might have already changed from when I made the example. By the way, my example is on GitHub, so I can send the repo later on if anyone's interested. Basically, what we're seeing here is two stuff. The first thing we see here is we have the use deferred value hook that React gives us. So what does use deferred value actually mean? What I'm trying to say when I'm using use deferred value, I'm saying stuff like this. If I have a change that is using this value, the input value, then I don't mind if the deferred input value will lag in 3,000 milliseconds. And I'll just show you a quick behavior, and then maybe we can deep dive into the code, and I'll explain how it works with the scheduler and stuff. And basically what we can see here is that if I start typing now Bulbasaur, and I want you to pay close attention to the frames per second. No, it looks like it's not working. Just a second. Sorry.
No, you're good. I'm still trying to figure out what the timeout here is actually referring to. Like, is it like a debounce or?
Yeah. So what everyone will probably think is that, yeah, how's it different from debounce? Why is it different from debounce? Looks like it's not working in the way I hoped it would.
I just saw it drop.
Yeah, it dropped. So I'm not sure what happens here. Just a second.
Yeah. So while you're doing that, I think there's a couple of approaches here. If a React developer wants to naively make an autocomplete, they would program it so that every time there's an on key up event, they would trigger some work, let's call it. But like you said, typing in BULB means you've done 3 pieces of unnecessary work. Plus, they could possibly show up at different times because of the magic of asynchronicity. You have issues. So then the next solution is, well, let's wait a few seconds or fractions of a second to let them stop typing and then do the work then. But then you're making some arbitrary decision around when the app should respond, and that may not match the user expectation. And then now we have option C, which is this magic thing we're seeing now.
Yeah, so I'll show it here now as it's working. I'm not sure why it didn't work before. Basically, we can see that the input is being updated as I type, and later on we actually update the list with the value that I actually wrote. So it's not a debounce, it's not a throttle, it's something else. And what's actually happening behind the screen is that if we can come back to the code. What's actually happening here is that I'm saying to React, okay, so I have an input value where I'm changing it in the onInput change handler, okay? So basically, whenever I call set input value, the input is changed, okay? Because in the search box, I pass the input value. So the search box actually gets the correct input value. It gets the input value as I type. And the Pokemon's list is getting a deferred input value. And the deferred input value, it has a configuration saying that the deferred input value may lag in 3,000 milliseconds. And that's not a debounce of 3,000 milliseconds. It means that in the worst scenario, if you didn't get to rendering it within 3,000 milliseconds, you need to do it now, okay? So probably in our computers and in high performance computers, we won't even reach the 3,000 milliseconds. It will probably happen before. Okay, so if we wanna talk a little bit about the scheduler or the scheduling mechanism behind this, is React says something like this: if I have a user input or an event that the user actually did, like hovering over a button or clicking on a button or typing in an input, that's something that the user has to see or has to know that something happened. These are events that have to get an immediate response, telling the user, hey, I saw that you did it. It's working, no problem. Some stuff may happen later, but I want to show you that I got what you did. So basically, these events have the highest priority. It's a user blocking priority. It means that whenever a user does something like that with that priority, it will be handled immediately. And what I'm doing when I'm using deferred value, I'm saying, okay, this input value or this deferred input value, it's not a user blocking priority. It's a default priority, and you can do that later. But before you do that, you have to take care of the user blocking priorities. Okay?
Yeah, that's kind of neat. I think the one thing that would be tricky for me if I were actually using it is like that 3,000 number. I feel like would be really hard to configure, just because like knowing like data sets can often like lots of times these are dependent on data sets, right? So you don't know necessarily how much data is coming back. And you also don't know like the processing power of the client that's actually executing this. So is there like any recommendations behind what to put in there? Is like there any way the browser can be like sort of figure that out for itself? Or or do you have to sort of take a shot in the dark at picking a number that seems like it works for you?
You know, I'm not so sure that might be the full question, because it sounds like if you were to rename this API, it would be, hey, go ahead and slip this work in when it's convenient, else do it immediately.
Yeah, this is like the fallback. Like,
right,
do this whenever, but definitely do it within 3 seconds.
3 seconds. And so the idea is that, you know, as the threads are busy, they can kind of slip this stuff in from time to time, right?
Yeah. So basically, the 3 seconds is yeah, it's pretty much a magic number where I'm using it at the moment. But I would say that it's not a part of our responsibility to decide about it, and I'll explain. When React came with Concurrent React, the main focus was user experience, and the whole idea behind Concurrent React is that it's based heavily on a user experience research that they did. So it means that probably the one saying, okay, I want to wait for 3 seconds, sorry. And if the time passed and 3 seconds passed and I'm still not getting the data, you need to do it now. It's something that probably the product will tell you, okay, we need to do that. And if it doesn't update until 3 seconds, you need to do it. You can't wait more than 3 seconds. So I'm not sure if that's a magic number, because it's not stuff that, it's more of a user experience stuff than a programmatic stuff, if I explained it properly.
Yeah, I think you did. It sounds like this is more of a in case of fire, break glass thing, and that we would really hope our browser isn't locked up for 3 seconds and can't get to this anyway.
Well, okay, so related question then, if from like the UX sort of perspective, if you wanted to tell the user that something is happening, so they typed in like, let's say Bulbasaur really is in production, like a super processor intensive task, right? Is there a way? Yeah, exactly. I mean, but if you wanted to show the user like some indication of like, hey, I understood that you typed Bulbasaur, right? Because in the current model, you type Bulbasaur and it does wait like basically 3 full seconds before the action occurs. And I can see that being a little bit jarring. Is there like a hook you have for like showing the user that like it's thinking sort of deal?
Yeah, so I'm not 100% sure. I think that I read something about is pending stuff. I'm not sure it's available for use deferred value. I'm 100% sure it's available for suspense for data fetching, which is a whole different aspect of concurrent mode or React concurrent. And I'm not sure that use deferred value actually has stuff like that. So okay. Sorry.
Well, there's always ajaxloader.info.
I don't get the reference, Dan.
Yeah.
Really? I wonder if it's still up.
No, Ajax is, oh, wow.
Pulling back like early 2000s techniques here.
This was the site where you could download those little Ajax loaders.
Oh, like the little,
remember that? And there was a bunch of kinds and colors, and now it looks like this is now a spam site with an offer, and as it is. So
yeah, in the early 2000s, I think I was 10. So
I remember using this in like 2006 and 2007. I was in charge of this really large application for a telecommunications company, and they had all these cell phone towers under their real estate portfolio. And the way all the contracts were written, they had no idea what cell tower was in jeopardy, but they knew they had to have a solid network, which requires cell towers in certain spots. So I wrote this lease scoring application, and basically this thing would provide a way for attorneys to mark up the leases and try to get them in some standardized format. And because it was so much text, I used jQuery. Thank you, TJ. And ajaxload.info. Thank you, John Knowles from our team, for resurrecting that thing. And then, dude, it was the new hotness, man. Everybody wanted their apps to have Ajax loaders.
I like on the site. So thanks, JK Knowles. And again, I hope I'm pronouncing that correctly. Found it, and I like that the site still has a thing that says, "Hey, this service is Web 2.0." That's
2.0, baby.
It's a blast from the past. All right, so back to concurrency. Because I have a lot of questions I want to make sure we get through here. My next one is, what is React actually doing under the hood to make this possible? Like, are they leveraging any browser APIs? Are there like web workers going on? Is there like something proprietary to React that's being used?
Yeah, so that's a great question. What actually happens is web workers is probably the first thing that we will think of doing if we don't want to use debounce or throttle. So no, it's not using web workers. It's actually creating concurrency in a single threaded environment. That's called cooperative concurrency. It means that if there's only one resource, we need to split the resource to tasks, and give every task the time to do some stuff. So basically what React is doing, and that's powered by the fiber architecture that went live on React 16, is that every component is actually a fiber. And whenever React finishes rendering a fiber, it yields back to the browser asking, do you need to paint? Do you need to do something as a result of what's happening? Am I not blocking anything? Did the user actually write something in an input? Did it click on something? So basically, the way that it's doing it is at the moment is by using request animation frame and a post message API. And these two are APIs that that are available in the browser for years, I think. And that's not anything new. There's not anything new in that scope. So that's basically the core concept of the React scheduler, which is called a user space scheduler, because what it's doing is it's actually scheduling only React's work. Only the stuff that happened within the React lifecycle will be scheduled that way. And what happens if I'm running on a site and React isn't the only thing that runs on the page? So these stuff won't be scheduled by React. And how will they cooperate together with that scheduling mechanism?
Yeah, I had to look it up because I remembered writing code that did have to feature check for request animation frame. So it's IE10 was the last holdout. So as long as you've dropped IE9 support, you should be good to go.
You can't drop IE9. It's Web 2.0.
But that does bring me to like a question, because I was wondering, like, it seems like concurrency, like all this stuff for React it's been out for a while now, right? Like, because I remember I remember seeing talks on it 2 or 3 years ago now. And I was wondering, and I know you're not on the React team, you're not responsible for this, but do you know why like this hasn't been marked in a more stable mode? Because it sounds like it's not browser support related. Is it just something that it really hasn't been tested? Is it like fairly far reaching in terms of what it can actually do?
Yeah, so basically, I think that the new Facebook web is using concurrent React, and what they are actually doing is they are dog feeding it, and they're using their own product actually to inside the Facebook, and they want to iterate and fix bugs and see some stuff that we're not actually that we don't actually know at the moment. So I guess, and for the tweets that I read. It looks like it will happen this year, but last year they said that it will happen last year, so we can't really know what's the actual status of concurrent React.
Okay.
Yeah. Basically, but if we want to get back to what we talked about, request animation frame and using post message to kind of schedule tasks. So these are based on a while loop that actually runs on a while true, something like that, and yields back to the browser whenever, or it's not really a while true. It's while I have fibers to render, just do this kind of stuff. And whenever it asks the browser or it yields back to the browser, it schedules a callback within the event loop saying, come back to me when you have time, when you finish whatever you're doing. Basically, that was the core work that the React team did. I think it was Andrew Clark and Sebastian. I'm not sure who else worked on it. So this is the core work for the scheduler. And from that, they went on and teamed up with the Google Chrome developers. And they actually went and built an API, a web API for scheduling tasks. And why is that good? I think that going back to the point that I said, React Scheduler is a user space scheduler. It schedules React job. And what happens if we have other stuff running on the page? So an API, a native API, is something that is pretty much required to manage these kind of things. And together, they started building the main thread scheduling API, which is actually behind an origin trial it means that it's behind a feature flag in Chrome 83, I think, and up. And we can probably see it soon. And the React core team actually started working on an implementation using that new features. I think that's somewhere around the last 2 weeks. So they're actually using or trying to work on using the new APIs. So they will be able to know and use these APIs that were actually built together with Facebook and the Google Chrome team.
Yeah, it would be very interesting to use the React user space scheduler and force it to render work in 3 seconds, and then use something on the native side that also was forced to render in 3 seconds, and have the work take longer than 3 seconds and see who comes out ahead. It's potential for some mismatches there, definitely some problems. So I can see if you can kind of bring that all into the native API, it might clean some of that fighting up, make it more consistent.
Yeah, so basically what React are trying to do is they want to tell you, you don't have to use the native API. We will use it for you. We will handle all the scheduling that happens in your page. And if we want to see the specific example, so this is the unstable schedule callback API that React has using the scheduler API, the user space scheduler. If we want to see the specific example, I'll show it in a second. But just so we'll understand what's happening here, I'm telling React scheduler, I want you to schedule a callback with the idle priority. Idle priority is the lowest priority. It means that, get to it whenever you have the chance. I don't mind, do that whenever you want. And so that's basically amazing if you want to start rendering ahead of time. If a user hovers on a link and you want to start rendering the page behind the scenes, and that's basically perfect for that. And what I'm doing here is I'm sending the analytics ping we saw before as an idle priority. It means that whenever the browser has time, it will do it. So if you want to see for a second how it looks like when I use the profiler for it, if you remember, I think I have it open here. Basically, the send analytics ping happened every time on every key press. We can see it here and here. What we want to see here at the moment is actually something different. We want it to happen all at once at the end. So looks like it happened already. Let's see.
And can you bump up the font size in this
sorry.
DevTools instance?
Yeah,
thanks.
Sorry, sure.
You don't have to go quite that big if you're having trouble finding it.
Yeah, you could probably go 2 down and still be okay.
Yeah, so we can see here that everything happened actually, if we want to see it here. So everything happened at the end. We have, I think
it happened at the end because basically you told it to idle process. And then when it was running that processing intensive task, the scheduler was smart enough to say, well, actually, we can't do this right now because we got some important stuff going on. And then when it's done, it's like, all right, let's see what we can clean up now that we're not doing anything.
Yeah, exactly. So whenever I say do it whenever you have time, here it didn't have the time to do it. Just a second, I'll close the. Oh wow, it's hard to do stuff in this font size. Sorry.
Yeah, no, you're good.
That's still fine. Yeah.
But these performance things are pretty gnarly. And sort of out of necessity, you just need I don't think you can do performance debugging without a good 20-some inch monitor sometimes, just because you need to see a lot of stuff at the same time. That's still plenty big enough, though.
Okay, cool. So basically, what happens here, as we said, everything happens at the end, and it's split into many small chunks here. As we said before, we actually have. Let's wait. You know what? We can see it maybe here. Oh wow. Yeah. So every dotted line is actually a frame. Okay. So we can see that here we tried to do as many Pokemons as we could. We see here that we have 1, we have 2, we have 3, 4. We have 4 Pokemons that actually happen within this frame. Okay, so every task is being splitted to many frames, as we can see here. So it looks much different than what we had before, where we had here I have an event press. I'm going to render all the Pokemons I can, or all the Pokemons I need, which is 200 Pokemons. So what happens when we see it here? And that's not because of the unstable schedule callback. It's because of the use deferred value. We're actually letting the browser do stuff and chunk it to between frames.
So the work is almost guaranteed to stop and start between frames, even if it's not completed.
Yeah. So basically, that's the power of concurrent mode. You can start something and then you can yield back to the browser. So it will have time to run animation frames and to run paint and layout and everything it needs, and then go back and continue from where you stopped.
So I know you just answered this, but I want to ask it even more directly. So you have work in your code that should span multiple frames, like the sleep. It's one discrete bit of work for a specific time that would generally drop frames before, and this concurrent piece is able to chunk it up and suspend it and keep it going and suspend it and keep it going until the work completes and still allow time for the browser to do the most important tasks.
Yeah, exactly.
Wow, that's really great, because think of trying to do that on your own.
Yeah, so that's actually the real power of React, so of concurrent React, that it splits the work it has to chunks, and it tries to do it between frames, and then just yield back to the browser and tell the browser, you can go ahead and paint and do whatever you need, and then continue wherever it stopped before.
And so just so I understand correctly, because you also stated this before, but I just want to make sure I got it. So currently, those APIs that are in the concurrent mode implementation of React, that's just React code, right? Like that's like you said, like the Fiber implementation. It's something built into React, and that they're working with the Chrome team to try to get some of that stuff natively in the browser, so they can basically React doesn't have to maintain that stuff themselves, and so it's more general purpose. But right now it's basically like a more or less the scheduler algorithm that's built into React, right?
Yeah, and okay. Basically what will happen whenever the main thread scheduling API will reach GA and everyone will be able to use it and browser support will be higher, they will actually just use the native APIs. So I had an example of the native API just for a second. I had it in Stash and I made some changes. Just a second.
Yeah, and while you're finding that too, I'll do a shout out to Chad. If you have any questions for Matan, we're coming up. We got like 10, 15 minutes here left to chat. So if you have any questions that you want to bring up for discussion, feel free to drop them and I will pass them along.
Yeah, so if we want to see what actually happens whenever with the native API, so if that was the React API, the unstable schedule callback using an idle priority, this one is actually the native API. So I'm using Chrome Canary version, so I'll be able to show it because it didn't reach master version, I think. Maybe it's also in beta. I'm not 100% sure. So basically what I'm saying is, hey, scheduler, I want you to schedule a task by saying post task. The task is just a function, run it, and the priority is background. Background priority is the same as idle priority that React has. Later on, if we'll have time, we can see the new implementation of the scheduler that actually has a switch case saying idle priority. Okay, so we need to use the background priority of the new scheduler post task. And basically what we'll see here is the same, I think. Just a second.
It's kind of an elegant API. Did you say, like, if I wanted to find the API, you said it's the main thread scheduling browser API?
Yeah, main thread scheduling. It's a proposal at the moment. It's not 100% ready for production. What am I missing here?
Yeah, scheduler.yield, scheduler.postTask is input pending. That's kind of elegant. I'll paste in the chat.
Oh, that's
To
what I'm
the
missing.
spec. I found it on Chrome status as well.
Yeah. So basically, the impact won't be different. What we saw before is exactly what we'll see now. Just so you'll believe me.
But you're believable. We trust you.
Oh no, it's not working. Scheduler. Oh, I'm not in the correct browser. Sorry.
Oh, not in Canary.
Yeah. Let's see it here.
Looks like you've done this at least 100 times before.
Yeah, I went into these bugs while showing stuff multiple times. Yeah, cool. It took me some time. I had a typo there. So maybe we'll see it multiple times. Okay, cool. So yeah, I wrote it 2 times. Here I had a mistake. I wrote B before the L. So we can see here the same effect happens. We have here the where is it?
Yeah,
Yeah,
I saw the 2 bunches of
yeah,
it. Yeah.
Here. So it has the same effect as the unstable schedule callback that React had without using the native API. Now we're using the native API, which is probably something that none of us will use because React will probably manage and handle that for us. But it's important to know how stuff are really working.
I think so. At this point, I'll put one last call out to chat if you have any questions to get them in. I think my last question is, so we've looked at some examples how this is done. I think from a pragmatic stance, I'd be curious when you think this sort of path is necessary and when it is not. Like, when do you know that I have a scenario? Like, do I look for like slow rendering and that's like my cue of like, oh, hey, maybe I need to like defer this? Is this something you think is going to change people's mental models? Like they'll think to do this first, like to defer things that aren't optional? Does it matter on the complexity? I guess what's sort of the thought process that goes through your head of, do I need to make this concurrent or do I just need to take the simple pass and just render this thing right away?
Yeah, so I think that the whole concurrent React paradigm is pretty much different than what we have today, because every developer, React developer, going to a code base now, seeing a performance problem, he just goes ahead and says, "Oh, okay, I'll use memo or I'll use callback or whatever. Let's just fix it and everything will be great." So the concurrent approach is pretty different because it says, okay, I accept that there's a slow render. I understand it and I understand the reason for it. And I can't actually change it because I have a slow render. What I'm trying to do now is to defer the problem and just give the best user experience I can within the limits that I have. So if I want to pinpoint the use cases, this would probably happen when you know that you have a performance problem and you know that that you can't fix it using or that you didn't do anything wrong in the process and you just have some heavy stuff going on.
Gotcha.
That last part's very important because this should not be thought of as a substitute for just randomly scheduling everything to avoid really writing your code well.
Yeah, because I think, like, to me, there's it's a tricky balance because this, even though the concurrent APIs, they're somewhat elegant, they do introduce a little bit more complexity, right, in terms of like when you're actually looking at your code and also debugging it. So I don't know if I'd necessarily want to make this my default because I think for most situations, your renders are relatively simple, but maybe if you're dealing with something that is a little bit more complex or you have a lot more going on, this is an option that you could look into, sort of deal.
Yeah, it's important to say 2 things, I guess. I'm not sure that the React core team is aiming for us to use unstable schedule callback. This is something that they are supposed to use. This is just like me trying to show the whole variety of stuff that the scheduler gives us. but it wasn't posted as an external API or something that we should be using. So that's the first thing. And the second one is that concurrent mode is actually still experimental. So we don't 100%, we're not 100% sure that we will actually look like this. And maybe stuff will change dramatically if we want to go back to use deferred value or suspense on the first approaches. The API looked far different, and what happened is that the core team showed it to the Facebook developers, and they tried to integrate it, and the developers told them, no, we can't do it. It's not really, it doesn't fit the way they thought it would. So they had to go back to the drawboard and think of a new API. So stuff like this still happen, and they can happen.
Yeah, well, at least they named it unstable underscore.
Yeah.
I kind of like that
really
convention too. I hadn't seen that before, but it's kind of nice because it's right there in your face.
And it's a really quick search through your code to see if you've left any of this stuff around. So let's see if we can kind of recap this. So basically, dropping frames is bad. Sometimes you can refactor yourself out of dropping frames, and that's what you should do. And if you can't, this set of APIs brings promise for offloading unavoidable work to a point that the browser can get to it and not block the UI.
I guess I know we are almost out of time here, but I guess I do have one final question that just popped up. So since concurrent mode is experimental and something your average company developer wouldn't want to use, if you have this problem today, is there a technique you'd recommend? Is debounce sort of your best bet, or what would you do in your production apps today when you run into this situation?
Yeah, so I'd probably use debounce because I think that every React core team member actually points out that you shouldn't be using it in production, and they don't guarantee anything because they actually tested it on Facebook. Maybe you have a different use case that they didn't cover. So I'd probably put my bet on debounce until concurrent React is actually stable and is released as a stable version.
Gotcha. Well, excellent. Well, Matan, thank you so much for joining us. I'm gonna drop if people have other questions for you when they see this, this will be up on YouTube later. Where's a great place to follow up with you? Is Twitter a good spot, or you have others someplace else?
Yeah, Twitter is amazing. You can find me at Matan Bobby, BOBI.
And I just pasted in the chat, so it's available. And to wrap things up today, one thing we'd like to do is just see if anybody has any plugs, anything they want to do. Dan, you want to kick us off with that?
Yeah, we curate the Enterprise React newsletter. So if you want Enterprise React news, just Google it, sign up. Our developers submit all the articles, so they're developer approved.
Cool. Matan, is there anything you want to plug? Any blogs, anything?
Personal projects?
No, you
pyramid
can find
schemes
me on
that you're going to profit off of. This fair game here.
No, you can find me on Twitter, and I used to blog at Medium or Dev2.
Awesome. And I'll drop it in the chat here, the React Wednesdays site. If you enjoyed this at all, we do this every Wednesday. Dan and I, Dan's been hard at work booking a bunch of people. I'm working on getting them on the site right now. So we have some pretty cool guests coming up in the next few weeks. So on the site, you can add the show to your calendar. I'm working on adding a little countdown thing so that if you show up on the site, it'll show a little countdown. That's my fun hacking activity for the next handful of days. So just make sure to check it out.
Mode.
Yeah, exactly. Need concurrent mode in there.
Matan, I'd like to thank you for taking this complicated topic and making it seem pretty simple, and also preparing the way that you did with the examples. I think this is a great topic for people to explore, and I can't wait to write this up and sort of point people back to you for the expertise. So thank you a lot for what looks like a very polished presentation.
Cool. Thanks for having me.
Awesome. Well, thanks again, everyone. Again, React Wednesdays, telerik.com. Make sure to check us out. We'll be back next week. So thanks, everyone.
Adios.
Bye. Thanks.